Hello everybody. I am making you another of our occasional series of supplemental bonus data visualization screencasts, so we can look at other ways of plotting data. We've looked at one of these so far, where we looked at using the Ggplot package to look at histograms, and now we're going to expand into looking at BOXPLOTS and beyond. So just as in the last exercise, we're going to be working with our Palmer's Penguin data. So I want you to sort of load in that sort of package, and we're going to be accessing one of the data frames packages in there called penguins. And if you remember, it has all these different variables. In this case, we can sort of see all the sort of different variable names present there. If we wanted to just look at the names themselves, we can use the function conames for penguins. This tells us what the column names are, and if we want to know what kind of levels are in our different factors. So, for instance, the species is a factor. We can look at levels of penguins, $ species. Now, to make our lives easier, I'm going to attach the data frame, because that will allow me to have to sort of skip over having to do all this stuff with the $ and calling out columns. It will make it a little bit faster to write some of these codes. Now, today's screencast is going to use the Ggplot package, as we've sort of used before. So if you haven't downloaded it, go and install it into your computer, and then you can load it into your active memory using the library function. And we're also going to be using a second package called BEESWARM. And BEESWARM is an add-on package, a supplemental package to the Ggplot that allows us to do other things. So we're going to get to. Now, in our regular lectures, we talked a bit about sort of using BOXPLOTS. And BOXPLOTS are a useful way of visualizing data. So in this particular case, I want to look at the flipper length of the Adelie penguins. And just to recap, the things that we see is the middle of the box represents the middle 50% of the data. That's known as the interquartile range, stretching from the 25th percentile to the 50th percentile. The line in the middle, well, somewhere in that box, is the location of that 50th percentile, the median. Now, whiskers extend from that box, and there's two situations it could be. The whiskers could either extend to the largest and or smallest values, or in situations where we have data points that fall more than 1.5 times that interquartile range outside the edges of the box, we call those outliers and designate them with circles. So in this particular case, we have at least one data point that is outside that range. And in this particular case, the whiskers extend to the largest and smallest values that are not outliers. And it's really important to sort of make sure that your audience, your readership, understands all the components of a box plot. Now, one thing that if we look in the arguments of the BOXPLOT function, one of the things that we could do is change the argument to add in a notch. And I'm going to show you what that looks like, and there you are. There's the notch. So the notch is somewhat controversial. It is a robust estimate of the 95% confidence interval of the median. It's sort of what it's often sort of described as. It's calculated as 1.58 times the interquartile range divided through by the square root of the sample size, and so it's meant to essentially give an idea about the 95% confidence interval for the location of the median. Some people like notches. Some people find them a little arbitrary and confusing. But I thought I would show it to you just because this is our supplemental, and you should know what some of the options are out there. Now, one other thing that we should sort of think about is the fact that that this is all well and good, and you can do all the adjustments that we've talked about in class, like rotating the digits on the y-axis with last equals 1, changing the color, whatnot. Now I'm going to sort of show you the basics of how we would go about doing this in Ggplot. So make sure you have that Ggplot package installed, and we're going to be using the function Ggplot, and we're going to be using the same basic terminology as we had in our last video, where the first thing we're going to designate is essentially the data that we want to use. The subset of penguin data using species equals a deli. And in our AES, our aesthetics, we need to put in the fact that it's going to be a species and build depth. And this is essentially to tell Ggplot which way we want to have this data plotted. That we're going to have the species on the x-axis, even though it's only one species, and build depth on the y-axis. If I reverse these, you would have a horizontal box plot instead of a vertical box plot. And then on top of that, we're then going to start adding in a layer. And whereas before we added in a geom histogram on, now we're going to add on another geom or geometric object called BOXPLOT. And as you can see, the grammar of graphics looks quite different here. They are going to be moving one row containing non-finite values. There was an NA value in that column, so it's going to not be able to handle that. And so here is our plot of things for our build depth. I do want to build depth. I wanted to do flipper length. Pay attention, Tristan. There's flipper length. See, that looks much closer to what we had before. And this one, so there's where we're at the moment. Now, what we want to do is we would like to sort of make this look nice. And there's a couple things that we can do to alter this from essentially the default. Now, so I'm going to put some code in, and I'm going to sort of walk you through it just so we know all the different components. And all these codes are going to be provided as a supplemental R file for you to play around with. And really, remember the key thing about all this is that data visualization is entirely subjective. What looks good to me is not necessarily what looks good to you, but there is no wrong way to pick colors or things like that. So when you're talking about things that look visually appealing, you are the audience. Yeah, I guess you can always think about other people, whether they like it, but ultimately think about, does it make sense to you? Everything we have up here is exactly the same geom box plot. Then we're going to change a couple things. We're going to change the color of the lines as well as the color of the fill to red and orange, just because we have all that customization. I'm doing that theme test, which is going to get rid of all that sort of gray background and provide a nice sort of border around it. Something I like. You can go in and sort of do infinite number of adjustments onto things. And I'll just, let's just see this for now. And I'll show you what I'm going to add on to it. So we did this. Here's our graph. And, there's a couple things here which are a little bit weird. First of all, we have sort of species and a deli, and it's sort of redundant because obviously there's only one species in this particular case, and so I want to get rid of this unnecessary a deli and maybe make this more meaningful. And here's a good place to write a deli, and obviously I want to change sort of my y-axis label to be more useful and more meaningful. So I'm going to add on some theme elements. The first thing is I'm going to changing the the axis text x, which is this thing that says a deli at the moment, and I'm going to say leave that blank. And now I'm going to then layer on and customize my labels. So I'm going to replace the default label on my y-axis, flipper length millimeter, and on the x-axis I'm going to write a deli penguin. And now our box plot looks much better. And you know, I also added in notch equals true. It has the same calculation as we have in base R, 1.58 times interquartile range divided by the square root of the sample size n. Now, box plots are very popular and very good. They do, of course, have some limitations to them. People have argued that you may be missing out important things, and there is a certain segments, factions, if you will, in the data visualization wars that argue that although this is miles better than having a bar plot with plus or minus one standard error, or a bar plot with 95% confidence intervals, that maybe we can kind of do better and show our data, the raw data that underlies this as well. So I'm going to show you a couple of different ways that we could do this. Some of these, you know, aren't better than others. It's entirely going to be up to you to think about what is the importance of showing things. So what I'm going to do is I'm going to use the exact same code we had before, and I'm going to layer on top of it another geom called DOTPLOT. And the important things I want to sort of talk about is that we're going to be binning based on the y-axis data instead of the x-axis data. We want to have the stacking of the data at the center, the width of the bins similar to how we were doing the histograms, so essentially where those sort of lines are made, and changing the color of the fin. So this is kind of like drawing a histogram on top of your box plot. You can obviously sort of do that if you wanted to, but that's a whole other thing. But this will give you kind of an idea. We're also just changing the color to blue, the fill is white, and we're making it semi-transparent. The alpha refers to this level of transparency, so this is going to be about 80% transparent. And I hit enter on this, and I'll get the same kind of warnings we had before, obviously that NA value is missing. And you can now see all the sort of dots sort of placed on top of them. And if I say wanted to make this like, you know, a bit less transparent, you can sort of play around with this. So this obviously plots every single data point that we ever had, so that can kind of be useful to your audience. And the fun thing with this is, you know, play around with the different bin widths and things like that, and to find out sort of what works for you. Now, there are other ways, of course, of presenting this data. This one is essentially presenting everything nicely organized in the middle. There are other options that are going to plot them, but just give it more of an idea of the data more in sort of a jittery box, and that's where we're going to use this Geom Jitter. So in this case, I've changed the shape. There's lots of different shapes you can have, and this is going to say, you know, keep the different sort of how wide do we want sort of the shape of that sort of box of data points. And so here are all those different data points, but randomly placed horizontally within this box. So you can imagine, so here's all the different data points, and they've all been plotted on there. So, this does show you where all those individual data points are. So there is, some value to it. Now, some people, of course, argue that this starts to look a little bit chaotic, and it becomes a bit of chart junk, where you're just trying to throw everything onto it. So perhaps there are other ways of visualizing the data. And one popular approach is to make what's called a violin plot. And a violin plot essentially is a density plot that is going to make kind of like a smooth histogram over the shape that we have before. It's often called a violin plot because it starts off skinny at the top and sort of has some ins and outs. And so I'm using the Geom Violin from Ggplot. And again, I'm going to getting rid of my box plot for now. So it's goodbye box plot. I'm going to make it light blue and make it about 50% transparent. So this essentially is replacing all this information here, and really sort of replacing it based on how many individuals you have. And so you can see it kind of looks like a violin. We see there's, this was a nice distribution where there's most of them are right in the center. But you can imagine in different kinds of data sets that if you have a bimodal distribution or anything like that, you can have all kinds of different crazy shapes. Now we can, of course, complement these two things together. I could add on a box plot on top of this. So add my Geom box plot on top of this. Of course, that looks a little ugly, not very aesthetic, really pleasing. Of course, we can also do things where we can change the width of the box plots. One of the arguments is the width, and make this 10% of the normal width of it, and then it starts to look a little bit more visually appealing. So we still have the same elements. And you can see that the box plot, the middle 50%, sort of matches up with this sort of wide part in our violin plot. And it's kind of nice. Now, we don't have to put box plots on top of things. We can also sort of put dot plots on top of them. So a dot plot is sort of like jitter, but essentially it's going to be placing individual data points on there. Again, we're going to be doing on the y-axis at the center. It's the same sort of things as we had before. And here is sort of that sort of data that with a few slight changes to its parameters that we have before. And you can see that the distribution of the violin plot matches the data set. And that makes sense because it's a density plot, that the more data points there are at a particular flipper length, the wider it's going to be. So this is a nice way of kind of visually representing this data. There are some other cool options, and these are things that are found in the BEESWARMS package that some people argue, might also be more aesthetically pleasing. One option is called the Quasi random Geom. And in this case, we're going to have the same data sets, but they're going to be distributed randomly up and down the width of any row. And so we're going to keep it confined to within the size of the Geom violin. And we're going to make them orange. And so now all those data sets essentially have been expanded out. So it really does sort of potentially sort of give you an idea, makes it look like more like a balloon that is being sort of filled out, and there's more molecules at the center than there are at the ends. Maybe kind of nice. And then so the last one we're going to have is the other package from a function from the BEESWARMS package, and that's Geom BEESWARMS. And what this is going to do is just going to try and organize these instead of into rows, into looking like, you know, cells in a beehive. And the two main parameters that we can change on here are the spacing between the points, as well as the size of them. And so again, you can play around with this. Here's what happens if I make these 3. What happens if I make this 5? You can get all. You can play around with something that looks to your sort of appeal for what things look like. So again, find something that you like, and when you're happy with it, then you are good to save it, and we can use again that gg save function. I'm just going to use the default settings and just call this a bees and save this a PNG. So and that's pretty much everything. I hope you have fun with all of this. Take care. Bye.